The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Good morning, students. I hope you all are doing good, safe in your house. Almost we have reached the end of this year 2020. It's going to be just 1 month more, and I know your improvement exams are fast approaching. Don't get worried, children. Prepare well, because you can do the best. I know if you prepare sincerely, if you can give your full commitment to your improvement exam, definitely each and every one of you will turn out to be a successful person. Okay, so amidst the improvement exam, you have to focus on your 12th standard classes also. So prepare yourself a timetable and then focus on both the videos. You can watch your +1 videos also. Now it is there in the channel, which is going to be helping you again. And also you can go on with the syllabus of +2, because it is on how you set your mind to prepare anything. So wish you good luck, children. Do well. Our sports day is fast approaching. We have just 2 more days to go, and it's going to be a great event because we have our 12th standard students participating as you are heading towards your end of this school days, right? So expecting great results to be there on the sports day. So let us begin the class for today with important compounds of D block elements, D and F block elements. In that we will be studying about D block elements generally, where they form oxides and oxo anions. See, we studied several properties about D block elements. We know they form different oxidation state, they are good catalyst, and they form colored compounds. All these we were learning. Interstitial compounds, they also form alloys, right? So apart from this, what we have to learn is that the oxidation number of the metal, as it increases, their ionic character actually it decreases. So as the oxidation number increases, their ionic character will decrease. This is with most of the metals of the D block elements, because we know metals actually they lose electrons and they get a positive oxidation state. They behave as cations, but as their oxidation numbers start increasing, right, from +2, +3 till +7, we were learning like manganese used to form a number of oxidation states. So in that case, their ionic character actually slowly it starts getting decreased. So with this concept ahead, we will be learning about preparation of 2 important compounds in D block elements. The first one is potassium dichromate. In potassium dichromate, we are going to learn about how chromium as a transition element form different types of compounds in the D block elements. So the first one is the preparation of potassium dichromate. In that, what is exactly happening? Now this potassium dichromate consists of 2 chromium atoms. So it is going to be prepared from chromite ore, which when treated with either sodium carbonate or potassium carbonate in presence of oxygen supply, it is going to form sodium chromate, iron oxide, and also carbon dioxide gas is being evolved. But the reaction does not stop here. Sodium chromate, which is formed in the first step, will be treated with acid, or I can say it is acidified with sulfuric acid to form sodium dichromate. There the sodium dichromate will be treated with potassium chloride to form potassium dichromate, where the sodium atoms are being replaced by potassium atoms. So this is how potassium dichromate compound is formed by the 3-step preparation. It's very important, children, because of all the D block elements we have only 2 important compounds that we are learning this year. So this is very important. If you see the structure, you have CrO4 2 minus and Cr2O7 2 minus, where though the structures are different, the oxidation number that they carry is the same. So if you see chromate ion CrO4 2 minus, it forms a tetrahedral structure, and if you see dichromate ion, it is forming 2 tetrahedron separately with a bridge of CrOC compound with a bond angle of 126 degrees, where the charge of both the structures are the same with 2 minus oxidation state. So I hope you understood the structure and the formation of potassium dichromate. I can say chromate and dichromate both are very good oxidizing agents. It plays a very important role in volumetric analysis of organic chemistry. And if you see in the last page, like before potassium permanganate, they are good oxidizing agents where the iodides are reduced to oxidized to iodines, sulfides to sulfur, tin 2 to tin 4, and iron salts, 2 salts to iron 3 salts. So some of the examples are given to you. If you remember, children, we were studying this in +1. In redox reaction, you remember, children, half type reaction and oxidation number, how to balance the whole reaction. So this is what you can see, the same example that is being given here. So with this, potassium dichromate is over. Now we will learn about potassium permanganate. Now we shall learn about the preparation of potassium permanganate. If you see, potassium permanganate is prepared by treating manganese dioxide, which is fused with alkali. It can be sodium hydroxide or potassium hydroxide, but we take potassium hydroxide because we want potassium permanganate, which is undergoing oxidation to form K2MnO4, which gets split into a positive and negative ion, where when you split this you get MnO4 2 minus. On acidified with an acid, you get your MnO4 minus, which is again manganate ion, permanganate ion and manganate ion. So this is a general preparation where you get a manganate ion here. But if you see commercial preparation, manganese dioxide when fused with alkali and with oxidized potassium nitrate, you get MnO4 2 minus, which undergoes electrolytic oxidation to give MnO4 minus. So commercial preparation, again I will repeat, manganese dioxide when fused with alkali and oxidized with oxygen or potassium nitrate, you get MnO4 2 minus, which is again undergoing electrolytic oxidation, you get MnO4 minus. So that's how we get a permanganate and manganate ions. See the properties, if you see permanganate, we have seen it's purple in color, deep purple in color like a crystal, but it is not soluble in water. Potassium permanganate, when it is decomposed, when it undergoes decomposition, you get K2MnO4, manganese dioxide and oxygen. It has 2 important properties. One is its intense color, which is very helpful for the to determine, I would say, whether a compound is aromatic or non-aromatic, or to find out whether it is saturated or unsaturated. Especially to find out the saturation and unsaturated compound, we use this decolorization with potassium permanganate. So it has got a highly intense color and it is paramagnetic because of an unpaired electrons. It has 2 important structures with permanganate and manganate ions. If you see in green color tetrahedral and purple color tetrahedral, one being paramagnetic and other being diamagnetic because of a lone pair of electrons or an unpaired electrons where it is not available in the purple color. So these are some of the important properties of permanganate ion. And it is also a very good oxidizing agent, where you can see oxalate ions being oxidized to carbon dioxide, and some of the reactions which they have given here. You have in acidic solutions where it is used to oxidize a given compound to its corresponding compound, and also in basic or neutral solutions. all around with 6, 7, 9 reactions are given children. At least learn 2, 3 reactions in each heading, which will be helping you to determine the oxidizing property of potassium permanganate. Definitely these examples which are given in the textbook, I am not wasting time on writing the board, it is already given in textbook. Please learn it very sincerely. Okay. Now besides the use, we know it is used in cotton, wool and silk industry also, and also for dyeing. And with this D block elements, that is transition elements, have come to an end. Now we will have a short description about inner transition elements, that is about F block. Okay. We will now see about inner transition elements. These are the F block elements which are placed at the bottom of the periodic table, and we know there are 14 elements which are also called as lanthanoids, and below lanthanoids we have another set of elements that are called as actinoids. Now we will learn about lanthanoids. We know what is the configuration, that is the outer shell configuration is N minus 2 F1 to 14, N minus 1 D 1 to 10 and NS 0 to 2 or 1 to 2. If you see the electronic configuration, 6s2 is a common subshell that comes in every single lanthanoids element, and it has a 4f, that is the electron starts entering the 4f subshell, so they are also called as F block elements. And we know F subshell can take maximum 1 to 14 electrons. What about its atomic and ionic size? See children, we have been learning this in S block, P block, D block. An atomic size represents the distance between the nucleus center and the outermost electron in the last shell. So if I see the atomic and ionic size, generally it has to increase down the group and decrease across the period. And we know there is an important cause for the shrink of the atomic size across the period. That is nothing but the shielding effect or the screening of electrons, or I can say an increase in effective nuclear charge. Here in case of F block elements or in the case of inner transition elements, the reason is just because lanthanide contraction. What is contraction? This is my nucleus, it tries to contract, that it becomes smaller in size. What is the reason behind that? Electrons present in the outermost shell has to be attracted to the nucleus, but there is an imperfect shielding of the electrons in the same subshell. An electron belonging to the same subshell does not do a proper screening of electrons. So if there is an imperfect shielding of electrons compared to the D orbitals, F orbitals are little bit less or weaker in the shielding of electrons, and this particular contraction of the atom is called as lanthanoid contraction. So the lanthanoid elements actually contract, so they are called as lanthanoid contraction. If you see the oxidation state, we have also been learning that D block elements and F block elements show variable oxidation state. The primary reason behind this participation of the F, D or S subshell is the reason that they have different oxidation state. But the most common oxidation state that we see in the lanthanoids are +2 and +3. That is just because of the extra stability of the half filled or the fully filled F subshell, because we know F subshell can take 14 electrons, so F7 and F14 becomes more stable. And if you see the general characteristic features, they are soft metals, they have very high melting point, they are good conductors of heat and electricity, they form colored compounds because of the F electrons. And uses, they are the primary use in making the alloy steel, where mesh metal, it's the name of a metal, a compound which has got wide applications in the commercial industry. It is also being used in the television screen. Some of the uses or points which are important in exam point of view, I have mentioned here. Also please go through your HSS live notes for extra information in this particular topic. Now we will learn about actinoids. With that, our 8th chapter is getting over. We have come to the last part of our chapter, that is we are going to learn about actinoids. Actinoids are the next set of 14 elements which are, most of them are radioactive. some are having a half life period, some are having a full life, long life also. And if you see the electronic configuration, just like lanthanoids with 6s2, the common here is 7s2, and electrons get filled in 5f and 6d subshells. And if you see here, the 5f subshell actually take part most in the chemical reaction, which again make them having a possible variable oxidation state, also behaving as a catalyst. Ionic size, as we know the general trend, it decreases across the period and increases down the group. The reason is because of actinoid contraction, because elements or the electrons which are in the actinoid series actually does the shielding effect, which is actually poor because of the poor shielding effect of 5f electrons. The 5f electrons in the 5f subshell has got a poor shielding as compared to that of the other subshells. So, this reason the actinoids actually contract, but not to a greater extent. Oxidation state, generally it is +3, sometimes it also has got a +4 oxidation state by loss of electrons, and these oxidation state they tend to hydrolyze very easily. Most of the metals are very highly reactive, of course having a magnetic property which is little bit complex to study as compared to that of the other elements in the periodic table. Some of the applications, if you see children, they have got a wide applications in the industry, like you can see some of the compounds are used in the pigment industry and also for dry battery cells. If you see dry cells and mercury cells, most of them has got D block elements and also F block elements. Of course, in nuclear reactor, you would have studied about nuclear fission and fusion, where uranium element is being used very widely in this application of nuclear reactor, and vanadium using as a catalyst, iron also again used as a catalyst. In also photography industry, if you see silver bromide, for the silver plate, photography plate, it has got a wide applications. So, in general, if you see D and F block elements, though they are very less in number, they have got a very wide application. So, this lesson is getting over by now, and I want you to go through the reactions, especially in this last part where we have the preparations are concerned, and in other areas you have to know the general properties of the D block and F block elements. So, from next class we are going to start a new chapter, coordination compounds. More of the use of D block elements you will see in that chapter. It's a very easy chapter, you will love doing that. We will be learning new theories in that also. So, I will try to include some videos children in today's class, and if possible, if you have any doubt, please let me know so that we can clarify your doubts then and there. Okay. So, thank you so much. Take care, stay home, stay safe. Bye.